Hey guys, in this one I'm going to be talking about balancing equations. Here we have this equation: hydrogen gas plus oxygen gas goes to water. And here's the visual. This is, don't ignore this bottom part for now. Hydrogen gas, two of them, the substrate 2, plus oxygen, two of them, substrate 2, goes to H2O, two hydrogens plus the oxygen. Okay? This is an equation the same as this equation, an algebraic equation, y plus 1 equals x. Now from algebra we know that x is equal to y plus 1, okay? And you also know that y is equal to x minus 1. How do you know that? You know that because of this equal sign. This equal sign tells you that the x will be equal to y plus 1. Whatever's on the right side will be equal to what's on the left side. The same with this equation, okay? Whatever's on this side must be the same as whatever's on this side, okay? One thing that I must point out in explaining this is that matter is conserved. Matter is never destroyed during a reaction. This symbol means a reaction is occurring, okay? And it's pointing that way, it's occurring that way. Alright? These are the reactants, this is the product. Just basic terminology. So now, because matter is conserved, that means that none of it is destroyed. So that means that whatever was at the beginning must be at the end. But we see that we are missing an oxygen. We see that there's only one, but we had originally two. This means that this is unbalanced. If we went to this algebra, this would mean that it's false. Okay? So what we can do to correct it is put some coefficients in front of these reactants and products to make the statement true. Okay? So the way that we fix this is putting a 2 in front of the H2O and in front of the hydrogen. So now we can look at it like this. We have two hydrogen molecules plus one oxygen molecule makes two water molecules. Okay? So now we can see that it's balanced because you have four hydrogens, you have the four here, and you have two here, oxygens, you have the two oxygens here. It's balanced. Now, balancing equations takes practice. This one was, as you will see, really easy. Let me give you a little harder one. Alright. Alright. From experience, I know that I must balance this with that side and then come back to the oxygen. But you will only know that after practice, okay? So practice for this one is your best friend as well. I have one carbon, so that means I will only have one of these. Okay. I have four hydrogens, so that means I have to have two more of these, right? Because two of these whole things means that each one of these has two, right? And I want to have a total of four. So that means that I need two more of these so that I have a 4 total. Okay? So that means we have 1, 2, and one of these. So now let's go to the oxygen. We have one of these molecules. So that means there's two oxygens for this one. And then we have two of these, and each one of these has one. So we have two oxygens. Okay? So we have 4 oxygens in total. So that means we must have 4 oxygens here. So that means we need 2 there. And that's how you balance that. So, balancing equations is practice. I think we have a little bit more time. This chapter is pretty straightforward. You just have to read it. A lot of the mathematics may get a little complicated, but you just have to work with it. I'm going to link some other YouTubers who explain this with more mathematics. In this series, I'm not really going to do too much math. It's just more conceptual. I'm not really going to go nitty gritty and do all the math out. I think that's really more on you, just practice. But if you really do need that help, then I'm going to link some YouTubers who really have exactly what I would be telling you. So what's the point of me duplicating them, right? So just click that link if you need it. One real quick thing that I'm going to explain is what a mole is. A mole is really simple to understand. Imagine you have a box of donuts, okay? 12 donuts equals 1 dozen, okay? So now think about the same thing, but in molecules. 1 molecule is equal, forgive me, 1 mole. 1 mole is equal to 6 times 10 to 23rd molecules. Okay? So this is a special way that we do things. Okay? Because when we have... I'm actually writing this backwards. You know what? No. That's messy. We need 2. We need 2. Okay. Wait. 2 oxygen. Yeah. I know I messed up. Okay.